All right, this is Advent of Code day 24, and I'm getting to this about a week late here. And I've actually already solved the problem, but basically due to travel and day 23 just totally kicking my butt. Just way behind on creating videos, but I wanted to at least come back and create a video for 24 and 25. So, and maybe I'll get to 23 at some point. My solution is just terrible, so I'm not sure it's worth showing to people at this point. But so 24 arithmetic logic unit. And so basically, I'm given these instructions for a little mini virtual machine here, and I'm going to do the instructions. There's always going to I got these four variables, four registers. It does say they all start with a value of 0, which is useful to know. No jump, so it's just going to run everything top to bottom. This is seeming like super simple, right? Like where I was like, oh, we can just do this. And basically, I'm going to input a model number here, and a model number is 14 digits, 1 through 9, no 0. And I need to basically each time it does a, let's see, where was it up here? Each time it does an input instruction, it's going to read the front of that thing. So if the input was 1 2 3 4 5 6 7 8 9 1 2 3 4 5, it would read a 1 the first time it got to this, and then a 2, and then a 3, etc. And it would read it into, in this case, the variable a. Now there is no register a, so it'd have to be one of these four. And let's see. And so we go through all this example of how to run this virtual machine. Basically, I'm going to feed it a 14 digit number, and it wants to know, and basically it's valid if at the end of the program the variable z is 0. If there's anything non-zero, it's invalid. And so it says, okay, what is the largest model number accepted? And you can already see from my answer that's going to come out. It's very close to 99. Starts with 9999. And so your first instinct on this isn't really not that hard. I'm just going to write a quick, basically I'll write a big nested if else loop that checks, what looks at this and based on the first verb here, does the actions taken with the numbers, and this seems super easy. And the problem is, when you run that through the puzzle input, it's just, the space is too big. You cannot brute force, 14 digits. It's just, or it just, by the time you try to run this, you're gonna have to run this for every, starting with 14 nines and going down. And even though you're not going down that far, it's not gonna work. Or it's not gonna work in any kind of time that would make any sense. Days, weeks type thing. So that's not going to work. So now the next step is we're going to start here, and we're going to start looking at our puzzle input and trying to figure out, is there anything we can do to make this faster? And very quickly you can see, there's this import W, or import into W, some instructions, and there's another import into W, and we expect to find 14 of those, because otherwise, we know we're giving it a 14-digit pin, and so we do find 14 of those if we do a Control F. And we notice very quickly they're very spaced evenly apart. And so, actually to visualize the next bit here, I jumped over into good old Excel, or in this case, LibreOffice, and I just copied and pasted so that, they were all next to each other. And you can see very quickly that there's these patterns where like each row is very similar. You can create a formula here, so we can do like, count if, and then we'll do for the range here. Now what you can do is we can say, if we did something like this, IMPW, and that'll give us count the number of cells that do not equal IMPW. So that you can see right there, the entire top row is the same, which is pretty obvious to the eye as well. So what I actually like to do here is, instead of saying IMPW, we'll say that, and we will put an ampersand to append, and we'll just put this last one here, and we can fill this down, and we can see which rows have varying values in them. And so right away we got row 5, row 6, and row 16 here are only ones that are changing at all. Every other one is exactly the same. So that's pretty cool. The other thing we can start to notice is that this row right here, row 5, has two possible values. It's either divide z by 1 or divide z by 26. That'll be useful. 6 is adding some number to x, and it's either positive or negative. you can see, and if we look here, it looks like whenever we're dividing by 26, it's negative, and whenever we're dividing by 1, it is positive. Yeah, it's positive, and it's not only positive, but it's big. It's bigger than, bigger than 10. And then down here we have an add, and I don't see any particular patterns here. This comes up 14 because they're all 14 different. This one comes up 13 because actually the 11 is repeated twice, or negative 11 is repeated twice, but that's not a big deal. So now we can start and take, what do these two things do? And so come here, we can put this here, we can do W, X, Y, Z. And so we're gonna input W, so that'll be like our input, but so let's call it W for now. Oh, there's one other thing we should look at here, and this is, well, we'll get to it, I guess. So this will be W, and so now we're gonna multiply X by 0 and make X 0. And there's another case, well, we'll get to it down here. Before we ever use Y, we also multiply Y by 0. So X and Y are not, really W, X, and Y are not carried between blocks. W gets reset with the new input at the top every time. X and Y both get zeroed out before they're used. So Z is the only thing that's continuing through from it's persistent from block to block, which makes sense because Z is what we're looking for as our output at the end. So if we come through here, so now we're going to add Z to X, and we're just going to call it Z here because, just to be generic, we'll have some Z. The first time it'll be 0, on any other block it'll be whatever it was. So in this case, we'll just get Z here. We're now going to mod this, so we'll do Z mod 26. Now in this case, for the first case, we divide them by 1, so we're still going to be Z mod 26. Add 12, so it's Z 26 plus 12. Now we're going to see if it's equal to W. Now this is interesting. Can W, so Z is going to be, Z mod 26 will be something between 0 and 25. So let's just say it's 0 for the best case, quote unquote, scenario. We add 12 to it, so now we have 12. Can W ever be 12? The answer is no, because W is 1 to 9. So no matter what this is, it's going to end up being false. So we'll put a 0, x becomes 0. And then when we do x is equal to 0, we're basically knotting what we had before. So, if x is equal to 0, now x is equal to 1, so we're going to get that. Now we're going to zero out y and add 25 to y. We're going to multiply y by x. So in this case, 1. So we're still at 25. We're going to add 1 to get to 26. We're going to multiply z by 26. So we'll have 26 times z here. We're going to multiply y by 0 to reset it. We're going to add w here. So we'll put a w. See if we can make this look a little bit easier to the eye by doing center. Okay. Now we're going to add 6 to y. So we'll have w plus 6. We're going to multiply z, or x, which is still 1, into this. So we're still going to end up with w plus 6. Fill that down. I don't know why you keep capitalizing that. I don't want to capitalize. There we go. And then we're going to add that to z. So we get 26 times z plus w plus 6. And that is going to be the case for basically every, the 12 actually is not relevant here, other than to tell us that we can't possibly succeed on this if. So for half of these right here, what we're going to end up doing is multiplying z by 26 and then adding the input value plus, a small number, plus this number down here, something between, 6 and 15. So let's look at the other type here, where we divide by 26 and we multiply, and then we have a negative number there. Put this here. We can do the same thing. So this is going to start with w. Let's make it nice and centered for readability. I wonder if this is small. I should make it bigger too. Okay, so we're going to do the same thing. In fact, we can probably just, well, I don't know how much this is going to copy, but yes. Okay, we're going to multiply x by 0. We're going to add z to it. We're going to mod z. This time we're going to divide z by 26. So z mod 26 over 26 is really just going to be floor, we'll just do z mod 26 divided by 26. And so basically what this is going to do is now all of a sudden we're taking this down a notch. That's useful. Did that turn out right? Let's we are hopefully I'm not doing this too fast. Mod this by 26. Then we're going to divide z by 26. Thank you. This doesn't go here. It goes z over 26. And that, I see, I made a mistake up here. This should actually be just z here. Okay, so now we're over here and we're going to put this, so we're going to have z mod 26, in this case, minus 11. Like that. Now this time, it is possible that our input is going to equal that, right? In fact, if our input is somewhere between 12 and 21, no, 12 and 20, we will have a valid 1 through 9. So in this case, we could have either 1 or 0. Then we can have 0 or 1 for this. We're going to multiply y the same, multiply this the same. When we multiply y by x, this time we're going to get 0 or 25. So we're going to have 1 or 26 here. We are now going to multiply z by y, so we're either going to have z over 26, or, let's not capitalize that, or z or 26 times z over 26. Make this, so, you know, we're either going to just get z over 26, or we're going to get what equates to kind of like a floor of slightly rounded down z. So z there, well, that'll be the same, that'll be the same. In this case, we're adding 11, but that doesn't make, that's fine. We're now going to multiply this by x, which is either going to be 0 or 1. So again, we're going to get 0 or w plus 11. So then down here, when we add this together, we're going to have either, two possibilities here, right? We're going to have z over 26, or, what's going on here? Okay, or we're going to have all of that plus w plus 11. And so it's important to note, you know, we have 7 of each of these. And so when we have these, we're definitely, the z is going to go, it's going to be going up times 26. And to get z back to 0, we're going to need to be shrinking it significantly. This one over here is going to take z and it's going to, it'll shrink it by a little bit, and then it's going to add some stuff. But if we have this first case, z is just going to get smaller every time. And so if we really, what we can say is, if we want this to be successful, we know this has the first, you know, this has to return true all 7 times it matters. And that should effectively cancel out this one. So how are we going to do that? Well, we know now that at every one, there's only going to be one valid w that works for those 7 digits. And that's good, because basically what it says is we can now reduce our brute force space from 14 digits down to 7 digits, and that's way more doable. I've already got the codes. I'm not going to write it here this time, but we can now that we know what we want to do, let's look at it. Let's see, get my terminal up here. So we're going to read in all the lines. And the first thing I did here was just run through the lines and pull the 2 constants. And the constants, basically each block is 18 things. And so I'll just loop over from I to the length of lines, stepping by 18. And then the first constant I care about and the second constant I care about are, grab them right here. So, you know, on line 0, 1, 2, 3, 4, 5, I got to get this one right here to see what this value is. And really, I could have also just got the line before and compared, is it 1 or 26? But in this case, I looked and said, is this 10 or greater? And I'll call that const 1. And then the one down here, which is plus 15, I'll get this one as well, because I need to get this for the offsets. And so here I have C1 and C2, and I'll just append that as a tuple to my consts. And that is just, that's a useful thing to reference going forward. Now you can see here from my comments, I originally solved this by just doing a for loop over this. I later turned it into a function. Either way, you know, that's useful when you want to solve it two different ways, and we'll see part 2 in a second. Let's see, is there anything interesting here? So basically I'm going to get the product. itertools product is a really useful tool here. Let's see. So if we do Python 3 from itertools import product, and I can spell. So if I do product, and I do, let's see, well, in this case, we'll just do something simple like 1, 2, 3, and then we do repeat equals 3. And we probably have to turn that into a list. Just to see what it is. You can see it does every possible combination. So it allows for repeats. Everything is 3 long, and so you're going to have 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 2, 1, etc. And so in this case, we're going to do repeat 7 to get the 7 possible. The 7, 7 of the digits are going to be set by the requirement, and so the other 7 we need to brute force over. Now what's a little bit tricky here is the required digits, the ones that are forced. We aren't going to know what they are until we know the pin. And but stick with me for a second, we'll get to that. So we're going to start off with this range 0 to 9 repeat 7. And the reason I do the range starting from 9 to 0 going down by 1 is because we're looking for the highest possible one. So we want that to be, this kind of overflow my screen, but we'll just, oh, that's too big. Okay, well, anyway, we want that. You can see it starts off at, what if I just do like that? Will that go quickly? Yeah. So you can see it starts with all 7 9s, then 7 9s and an 8, 7 9s and a 7, etc. And that way I am getting the highest possible ones. And that's useful. So the next challenge here is, oops, what did I do? The next challenge here is, so I'm going to then loop over all of those, combinations of 7 digits. I want to create a pin out of this in such a way that I need to create the pin, but I want to insert those things I just, these 7 9s into the place in a very specific place here. And the way I did this is, and this is to create a thing called, pass it into an iter basically. And what that does, let's see. So if we do, let's just say prod equals, this is what we do. I'm just showing kind of how I did it here. If we do that look right? Yep. And I do x equals iter prod. Now, if I call next x, it's going to give me the first one. And every time I call next x, it's going to give me the next one out of that iteration. And so what's useful about that is, now I can come in here and I can define myself a pin. And basically what I'm going to do is I'm going to say, I'm going to loop over actually the constants. So we know that's 14 long because I pulled it out of the 14 blocks. And I'm going to loop over the constants. And for each one, if C0, so this first one, I don't know how I must have done this in some Vim mistakes here. That's, oops, that's a 1. If the first one, what was C1, is greater than 9, then I'm going to just put a 0 there. Because if it's greater than 9, I don't know what it is. I'm going to have to calculate it later, but it's forced. It's not involved in my brute force. Otherwise, I'm going to put the next digit here. And so in this case, what I've actually done here is I've said, because I'm looping over these, I've said prod equals, let's just say, let's get one of them like this. Oops, I guess I need to list that. You don't when you're looping, but for this demonstration. And then when I do x equals iter prod, if I do next x, I get the 9, then I get the next 9, the next 9. Probably a bad example because I picked one that has all 9s. If I do 1000 or 100, click something in there. So it's a 9, 9, 9, 9, 8, 7, 8, etc. So that was my thing. And it actually throws an error when you try to get past the 7th one. So that is all to say, that allows me to create this pin. And what this pin is going to be is I'm going to have zeros and the things that have to be something. I don't know what they are yet. And I'll have the digits I'm trying to check for my brute force in the positions where they belong. And so I can actually print that there. That's more of just a debugging thing. I will then set z to 0, and I'll do basically what I was doing there. And so I'll enumerate over the pin, and for each character, I'll start with, I'll get the constants I need. If C1's greater than 9, that means that it's not, that means that this is one of the things I'm brute forcing, so my pin is already, the pin position at this point is already set. I will use that to, I've got the W here, so I will update Z by making it bigger, multiplying by 26, and then adding this stuff, and then looping around. And then else, if I get a C1 that's less than 9, so that is where I do know the pin has to be one thing, so I don't know what it is, because I've just got a 0 holding place right there. And so what I'll do there is I will set that based on knowing what it has to be. And then if I get a pin that's illegal, so let's say this pin, based on my input, let's say the requirement there is it's not going to fit based on what's been happening up here. Then I'll just break out of this loop and I'll get out of this pin and go to the next. I break out of this for loop here. I come back around, I get the next product, and I start running through. And so if I reach the end without breaking, I'll check and see if z is 0, and if it is, I will print it and return. Hopefully that makes some sense. Let's see. And so then simply we just run it. What day is this? 24, and we'll call it 24 and we run that, and part 1 solves very quickly. And you saw that's the answer. That answer does match up with what I put in here. So we get to part 2, and it says, oh, actually, sorry, you don't need the biggest number, you need the smallest number. And so that's what you saw start running there. I guess I should have left that running. And this takes a second to go through, but it's going pretty fast here, and you can see we're making progress through the space, and it's actually in the 6299. We find the result. I don't know if people care about this, but I am a huge fan of anything that takes some time. I love it when I can show the progress being made by printing that out. And all I'm doing here for that is when I print these pins, I'm printing them with an end of nothing, so it doesn't print the new line. By default, end is a new line, and I'm putting a /r here. And /r at the beginning of the print actually moves the cursor back to the beginning of the line, and so I'm just printing over myself. And then when I do actually get a result, I do a print. I still have my R to go back to the start of the line, but this time I don't set the end, so it just prints nicely. And as long as this is longer than what I've been printing here, it just steps over it. So I'm going to go ahead and call it there. That's day 24. Hopefully this was useful, and thanks for sticking around till the end, and I will talk to you next time.